Okay, welcome. June, hot June, first day of summer, over 90 degrees. Okay, I'm just going to go through this intro quick, and then I'll pass it off to Ian and Carol for our presentation today. So as a review, these monthly meetings are on a variety of topics, often the actual EnviroDIY monitoring stations, overall stream monitoring, science, watershed science concepts. Data to action is what Ian and Carol are going to be talking about today. We often do talking about tools such as the Wiki Watershed tools and then other topics. So agenda, I'm going to go through updates, and then these two sections are just going to be merged today because the presentation is from the work group, and then hopefully we'll have a little time for discussion. The meeting is being recorded. It's available at this website along with a lot of other resource materials. Meetings are every third Thursday of the month, 2:30 to 3:30. Zoom link is always the same. As usual, I send out meeting updates via our distribution list. If you have anyone that would like to be added to that distribution list, please let me know. Delaware Watershed Initiative is funding Stroud's support for this. And people who are attending are working within that DRWI effort, as well as folks just within the DRB. And we do get some folks from outside the Delaware Basin. Also paying for some of this work with Seesaw. DRWI 4 States 1 Source website. Seesaw available for Stroud to provide assistance to groups in the state of Pennsylvania. The South Center team on this community science effort. Me, Krista Reeves at Musconetcong and Stroud, and then Shannon Hicks, the engineer. Lots of master watershed stewards involved, a few prominent ones being Carol, who's presenting today, Joe Devis and George Seeds. Stroud Center leads on the DRWI overall, John Jackson, Matt, and Dave. So primary goal of these meetings is to support station owners and managers and volunteers with using EnviroDIY stations, doing monitoring themselves for their own local purposes. And then secondarily, the Stroud Center is doing data analysis and developing tools along with collaboration such as the work group it's going to be presenting today. So I'm just going to go through some quick list of updates. So, just as a reminder, Stroud is available to support doing these snapshots, just overall monitoring, project design, protocols, so on and so forth, doing data analysis, interpretation, and so on, and overall watershed education. So feel free to be in touch if you need support. Also, if you have any, stories, updates about what's going on locally in your watershed or watersheds, feel free to let Diane or myself know. Diane's actually on leave right now, so I guess for right now you would just send to me, and I can pass on, and those can be shared via Stroud's social media. There is an EnviroDIY workshop on August 13th and 14th at the Stroud Center. So 2 full days. At that link, there is a description of the workshop. It is not a full CTD build from scratch workshop. It's a little bit of a different one where it's just learning about in a little more detail about how to program the loggers and there will be discussion of building a CTD station, but folks are not going to be leaving with a fully functional CTD station. So this is more of a foundational EnviroDIY workshop. So
David, may I ask, could you just explain a little more? So this is for people who are already using one of the sensor stations and
it could be for folks that are, it could be either. It could be folks that are already have a station and would like to sort of understand it more deeply. Um, Especially sort of the coding and stuff like that, or the installation and all of that. But it's also for, you know, people that don't have stations that are interested in building their own CTDs or any other applications. So it's just a little more of a, it's not the standard intro workshop where it's just programming of a few small little sensors. It's more comprehensive than that, but it is not a, it's not the type of one where you are buying all of the supplies for your personal station and coming in and assembling it. But if anyone is interested, feel free to check out this website. Just go to EnviroDIY.org and then just go to events and it'll be in there. But feel free to be in touch if you have any questions on that. So I am going to stop there and switch presentations and bring over, or no, actually, I'm just going to stop share and Ian's going to share his screen and do the presentation. I see it, Ian.
Sorry about that. I was just adjusting where the bar was. It was blocking everything. Hello, everyone. So today we're going to be discussing about the efforts of what we've called the Policy Practice Work Group. Our full name is Delaware River Basin Policy and Practice Work Group. Current members that we have are listed here. We have had multiple members who have been on the work group but have since left. And we appreciate all the contributions that they have done. One of which is David Manning, who unfortunately has resigned from the group despite having contributed much to the documents that we have created thus far. And I wanted to extend gratitude to him for doing as much work as he has. And we look forward to keeping in contact with him. But he is no longer a part of the work group. Maybe that'll change when availability comes up. Initially, we had created a charge after gathering together sometime early last, I think that was 2023, January 2023. We had started this group in an effort to take the data that our data sensors are collecting and figure out ways to communicate what the data means so people can make actionable change. With that, we created this initial short-term charge, which has carried us through to where we are currently. And it had directed us to the creation of 5 documents, one of which we have not even started, which is a turbidity document. However, we have completed the municipal and temperature primers and are nearly completed the conductivity document. We have also started with the depth document. These 5 documents are intended to be in-depth, detailed, but digestible to the average populace, to learn how to speak knowledgeably about these topics when engaging with their municipal partners, or at the site of at Riverside conversations, because sometimes you're approached by onlookers who are seeing you do maintenance and they ask, what are you doing? These documents can also be useful for having those discussions as well, because you can talk about each of the various main aspects for what our EnviroDIY sensors are collecting. Along with these primer documents, we are also in the process of creating supplementary documents, including executive summary documents, which are a consolidation of the primer documents into a smaller, more digestible, more distributable form, as well as subtopic summaries documents. Although we necessarily will not, we might not necessarily be the ones who are creating it, we do encourage people to take our primer documents, use and distill the information there to create subtopic summaries that might suit their purpose, whether that's more community-specific documents, such as when you're going to municipal meetings and trying to persuade people that maybe an alternate land use might be a better for the environment, or whether you are trying to do an education program talking about your watershed. These community-specific documents can be very helpful in those areas as well. And with this is an example of Broadhead Creek, who created something similar to what we had in mind for a one-pager. Although they did not utilize our primer documents to create this document, this is a good example of what a one-pager could look like using coming out of reading our primer documents. And with that, I'm going to hand it over to Carol, who will walk you through the primer documents. Carol, you're going to need to unmute yourself.
About that. Sorry. Let me get my notes back here. So the materials more specifically are for people on EACs, various people from volunteers to leadership in watershed groups, and basically anyone who's interested in participating in local decision making. So the material is digested, but it also provides some very what's the word, not just expert, but the references of people who have gone deeply into certain subjects to kind of get you going if you wanted to work on something more with a greater intensity, I guess. Can you change slide? So this is a little repetition. So as we said, putting stream temperature data to work is up and available. Putting stream conductivity data to work is being completed. Putting stream depth data to work has been begun. There is the tools for working with municipal leaders, and also each of those papers has a section on how to engage with municipal leaders as well as a standalone document on that. So this is where they're located. They are on Wiki Watershed. They're on a tool called Manage My Watershed. Under Manage, they're listed as under tools for engaging with municipal leaders on freshwater issues, and there is the URL for it. Could you switch slides? So my plan here was to give you some highlights from the temperature and conductivity documents, just to give you a sense of both the breadth and I don't know if I can say the depth, but the specificity of the issues that we're trying to address. So the basic structure of the stream temperature document is, sometimes we call it a primer, depending on your pronunciation. I don't really know what we don't really have the correct title for these things yet, but it includes the determinants of stream temperature, temperature thresholds, for various aquatic organisms. Whoops. How aquatic species adapt to increasing stream temperatures, land use and development of concern that affect stream temperatures, and when and how to approach municipalities based on temperature data. And there are, various graphics showing some of the dynamics of how stream temperatures rise, and some tolerances by the EPA for macroinvertebrates and so on. Okay, yes, could you switch now? So some of the determinants of stream temperature that are discussed in some detail in these papers are the atmospheric, air warming or precipitation sources and groundwater sourcing of increasing temperature, the dynamics of solar radiation and the impact and seen as through seasonal variations, and the depth of penetration of solar radiation. And then there are seasonal and diel variations or deal variations that, and the interaction with stream order, so that the variation itself increases with increasing stream order up to, down here is a graph from a well-known Venati paper showing that it increases up to stream orders of 4 and 5, and then that variability, that variation of diurnal temperature decreases as streams get larger. And this is a deal, very interesting graph from someone's study showing how during times of basically warmth, high solar exposure. Oh gosh, I've got all these noises going on here. Let me turn this off. During the daylight hours, the stream level will drop as temperatures are at their peak because trees are pulling in more water from the stream. And then at night, as the temperatures cool, the stream levels will increase again. So again, I'm just going through some highlights. I think this audience today, I know, is aware of many of these topics. Just trying to let you know that we give, authoritative bases, papers that have tested and explained how this knowledge has been gained and why and if it's valid. So let me check my notes here, sorry. I don't know how much more to get into it here. I guess the atmospheric and groundwater sourcing is an issue because as streams get larger, they tend to be warmer with proportionally more water coming from tributaries than from groundwater. Obviously, the tributaries and forest catchments will also bring colder water to confluences. So it's, a lot of factors to take in account in understanding a stream that you may be concerned about and understanding where and why temperatures might be rising in parts of it. Although overall, globally and in various regional assessments, stream temperatures are increasing with climate change, with climate heating. Surface to volume ratios, so larger streams with greater surface to volume, ratio, they can absorb more solar radiation. So that's a solar contribution to stream heating. Streams conducting more surface and subsurface water during storms can also bring more heat as that water runs off from human used areas. So urban heat island effects can cause longer term increases in temperature even after the storm event. All right, thank you. So there's, as I said, each chapter we try to cover something on the ecological impacts of the issue we're discussing. So in terms of stream temperature, what we've addressed these are some of the main ideas, but there's more in here. So adaptation of fish to temperatures. So as you all may know, fish, there's a certain temperature range starting, I think it's 68 degrees Fahrenheit, when the physiological stress responses, respiratory, cardiac, get stimulated in fish. And when it gets up to beginning around 74, 75 degrees Fahrenheit, it becomes toxic. So lethality is a problem. Then fish behavior, fish adapt as individuals, as well as, there are certain patterns that have been seen. Some of the patterns are that fish spend more time in thermal refugia, which are pockets of cooler water in the stream. And so fish, if they have access to the stream system, they'll identify where those thermal refugia or thermal refuges are. But because they, during heat, will spend more time in thermal refugia, they'll spend less time in forage patches where food is available. So, scientists are studying that interaction between they think that perhaps the thermal refugia that are closest to where the forage patches are may be most may result in best outcomes for fish. So there are different impacts from temperature on main stem and tributaries. Let me see here. Yeah. So other factors that affect aquatic species survival are, as you know, deoxygenation that can occur as stream temperatures rise. Fish can be seen as gulping air if they are threatened enough, if they're physiologically threatened enough. So that's a definite potential threat. Catch and release, which is thought to cause about 10% mortality, fishing method. That mortality increases in higher stream temperatures. And overall, the issue of stream connectivity is discussed in the chapter because that connectivity is needed for various things, including forage and the use of thermal refugia that are available, and therefore the productivity of the ecosystem, of the stream ecosystem. Population survival during stressfully high temperatures, as I said, may be influenced by how close refugia are to foraging locations. So restoring, so it becomes a management question as well, restoring stream connectivity, such as by removal of weirs and dams and maybe culverts, or other ways to restore temperature, such as releases from a reservoir, could restore migratory pathways that allow fish access to more diverse thermal regimes and more diverse and more thermal diversity. I think that's it. Thanks. Let me see my notes. Sorry, I'm looking at two screens at the same time. So each chapter, we also look at land uses that affect the subject of interest, in this case, temperature. And we include, for all of these, the background of these, of why we know that land uses causes these, interacts with the problem, with temperature or conductivity, or causes, I'll just leave it at that, as well as the studies that have built the evidence for it. So of course, big topics are deforestation and what are the most effective buffer widths, most ideal buffer widths. Also types of impervious surfaces, so different types of impervious surfaces and their impacts on water quality, stream ecosystem, wetland plant and amphibian community. So all of those issues are discussed in this chapter. Then there are impoundments, which include dams, and the height of the dam is an issue affecting temperature. Volume of the dam affects temperature. The widening of the impoundment, as well as ponds, lakes, weirs that impede flow, and even our, stormwater basins that are built so often to mitigate the removal of mature trees for development. Those can all increase stream temperature. And I think it's important for, municipalities or whoever you're appealing to understand that all of these actions that we take may have side effects or unintended consequences and are part of the development that we're doing that affects, stream health. So then there are the discharge of heated effluents. Of course, I include roof drains in there because there are, people can manipulate their own gutter drains essentially, and roof drains, and they, sometimes will send them straight to the stream. So that becomes a source of a kind of heated effluent. Also wastewater from chemical plants, from various types of refineries, and from power plants. There's a lot of documentation, government and technical, on the issue of power plant heated effluents. Again, as I said, background and studies are part of these papers. And then stream flow depletion through pumping of surface water, as well as groundwater depletion, are both causes of temperature increases. As you know, groundwater depletion pumping is a particular problem in the eastern coast, because it's causing more subsidence of and greater sea level rise than other areas of the country, in part because of the groundwater depletion that's occurring. So I know that's a side point, but I make it to say that we're doing a lot of stream and groundwater pumping. Okay, next one, please. So now I'm going to switch to stream conductivity. These are some of the issues that we've addressed. One is understanding what stream e-conductivity is and its underlying ions, understanding different types of ions and how they interact. There are geological influences, of course, to stream conductivity, including what happens when ions decompose, also rock dominance underlying the stream, weathering of rock, and carbon dioxide are all influences that affect the increasing conductivity of our streams. Then it's been shown that human activity in general causes an increase of stream ion concentrations. Next one, please. So also covered in this is the subject of freshwater salinization. This basically means increasing conductivity in freshwater systems, including surface waters and groundwater, from total dissolved solids, which includes organic and inorganic, anions and cations. So, excuse me. So the salinization is part, as I said, is not just for surface waters, but also groundwater. And then it's caused by anthropogenic runoff of salts into fresh waters, chlorides, into fresh water at a faster rate than they can be naturally flushed out. And the major sources of inland salinization are wastewater treatment plants, roads and parking lots, agriculture, and irrigation of dry areas that lack adequate drainage. And I just want to point out in this graphic from authors that are credited in the in the document, shows that there may be saline, depending how close, I guess, you are to the coast, or even how close you are perhaps to inland seas. I don't know. There may be saline water very, very deep down below our groundwater, but that can be upconing due to changes that we make in groundwater. So this is I'm not going to take us through everything in this graph, but it's a great demonstration of how our manipulation of groundwater and our use of salts is getting into different levels of our aquifers, essentially. Also, increased evaporation and decreased precipitation will increase freshwater salinization, and they have been accelerated by climate change, again, excessive groundwater pumping, and industry that dispose of wastewater with high salt levels. basically by, excessive groundwater dumping, specifically by development, by the way. Okay, next slide, please. So then there's freshwater salinization syndrome, which is a little more complicated, but also just as concerning. So freshwater salinization syndrome is concurrent increasing trends in conductivity from increasing chlorides, in pH, in alkalinity, and in base cations. So it's basically the complex interaction of chemicals and specific types of ions, and interaction of salinity and alkalinity. So it's being again caused by salts, such as road salts and brines from fracking fluids that are increasing both salinity and alkalinity. And freshwater, if you look at the box at the right, freshwater salinization syndrome has affected 37%, has affected, that has changed salinization of fresh water of 37% of our fresh water, and alkalinization has increased in 90% of our fresh water of the drainage area of the contiguous United States, and it's been a most rapid change in the eastern United States. So we are changing basically, the nature of our fresh water and what it's going to be available for if it becomes overly salinized or alkalinized. So there are many different, some of the salt ions that are involved in salinization are toxic to aquatic life. And as I said, human accelerated weathering of natural minerals also drive both salinization and alkalization, and that's explained in the document. All of this is. And the threats are to, I'm sorry, let me stick with that prior point for a second. So the human accelerated weathering of natural minerals, as I said, drives both salinization and alkalinization from excessive salts containing strong bases. Those include sodium, calcium, magnesium, and potassium, as well as carbonates with potential for acid neutralization. So it's this complex interaction of this chemistry. Also, agricultural use of minerals such as lime and urbanization reliance on concrete are weathered more rapidly by acid rain. All of this the freshwater salinization syndrome essentially threatens the safety of our drinking water. So it's going to shift completely over time, it's showing increasing shift of how much drinking water is safe in its natural form without requiring treatments, other than pathogens, I guess. Also, ecosystem health, biodiversity potential, human infrastructure corrosion, and food production. So it's very, a landscape-wide problems. Okay, could you switch slides? So the ecological impacts of high conductivities in general. So in our local area, the Delaware River Basin Commission shows that chlorides are trending higher through their last data point of 2020, and the USGS, looking at individual streams out to 2022, shows that that trend continues past 2020. When the conductivity is between 500 to 10,000 microsiemens per centimeter, then organisms require more energy to maintain their osmoregulatory balance of water and salt in their bodies. This balance can stress and impair those organisms and cause species to have to adapt within their aquatic system, depending on their ability to move within the stream or surface water. That is, they need to maintain salt and water balance across their cellular membranes within their body's fluids. So once again, I think this is, although connectivity doesn't come up as a topic in this section, I think again, it shows why aquatic animals need to be able to move within their stream systems. That's, you know, called conductivity. So benthic invertebrates, they want to, you know, they thrive in low specific conductivity waters. But in areas with high natural background conductivity, they can find lower conductivity niches. And there's a paper that developed a model that can be used by Cormier's first author, that can be used to understand what the basic extirpation threat is for benthic invertebrates in whatever your stream of concern is. So the EPA has found that a good mix of freshwater stream fisheries, conductivity will range from 150 to 500 microsiemens per centimeter. So that's kind of a benchmark. And, let's see, I talked about the Cormier paper actually as a model of tolerance for conductivity that could be used for trying to actually manage conductivity inputs, I guess, or conductivity threats in a particular watershed or stream. Also, there are conductivity impacts. There are impacts of freshwater salinization on food webs due to the chemical cocktails. And that's a really, to me anyway, interesting issue, showing how, again, aquatic animals will tend to try to depend more on sources of nutrients that are external to the stream, but that the chemical cocktails makes it complicated. And then this section also includes the impacts of conductivity on crayfish, fish, and fish. It's very, to look at the conductivity tolerances of fish, it's very stream specific, setting specific, but there are I guess fewer studies, but also helpful studies showing how crayfish and salamanders are surviving and adapting or not adapting to streams with high conductivity. Salamanders, I'm referring to stream salamanders. Okay, I think that's it. Next slide, please. So some of the land use is causing increased conductivity. Food processing facilities actually are emerging as, or I don't know, they've been known for a while, to have wastewater that have a lot of metal ions in them. And in fact, there is a recent Pennsylvania House Bill 2393, which is entitled Keeping Farms and Communities Safe by Managing Residual Food Processing Waste. This bill hopefully will get out of committee, but this bill it requires food waste to be digested before it is spread on agricultural fields, and that there have been actual complaints both from community and from I think some commercial sources of contaminants coming from that food waste. So food waste facilities actually are a problematic cause of increased conductivity. So for example, electric conductivity that's been recorded has ranged from 20.4 to 1,487 microsiemens per centimeter, and distilleries in particular, their effluents were up to 5,100 microsiemens per centimeter in the stillage. And as I said, I haven't said this, but citizen activism has raised food industry's awareness of the impact of their wastewater and stillage on the environment. Then I think we're more familiar with wastewater treatment plant effluents from household products, food, industrial discharges, and human waste. These all contain many chlorides. And I think the degree to which chlorides are removed from wastewater is variable. I don't have a lot of there are, you know, the EPA and states have set specific chloride levels for different locations. So I think there's some regulatory control, but these are sources of high conductivity. And then direct industrial discharges, those that discharge directly to water bodies without significant treatment, that still occurs. Congress has set national pollution control requirements for each industry based on the best technology that the industry can afford, but local regulations can also have impacts. So that's appropriate to raise a management issue within these documents, I think. And I think that's my last slide. Thank you. And I'll give it back over to Ian, who's going to end our presentation.
All right, thank you, everyone. I just wanted to leave it here with a brief recap of future steps. Our next topic that we're really going to delve into is the depth document. And then after that is potentially the turbidity document, depending on the amount of resources that we can pull for that topic in particular. In the meanwhile, if you have any ideas or literature you want to share with the group, feel free to send that to David, myself, Carol. David has our email addresses if you need to get in contact with us. Now we're going to start open this up to a Q&A. If you have any questions for the group, we have a couple other members from the group here. So if you want to ask us any questions about where we're going, what we've done, what we've or how to best utilize the documents, though this would be a good time.
Ian, do you want to take off screen share there?
Sure.
All right. Questions, comments, suggestions, ideas, thoughts?
I'm going to give a suggestion, or actually I'm going to tell you what I'm doing, which is I'm distilling the stream temperature document down to important points for my municipality's planning commission to consider in their work, including data that's specific to my township. So I'm adding some data in, you know, the basically development and the trends in development that are occurring. So I think they've said they would welcome that, and so that's one possible use.
That's great to hear, Carol. I'll look forward to seeing what you come up with, and be in touch if you want me to whatever review,
Yeah, thank you.
or the work group, maybe the work group even as a
Sure.
whole.
Mm-hmm.
So
Yeah, go ahead.
Carol, go ahead.
Well, I can't tell from the silence whether people think these might be helpful or not, because if we're off track, then we need to learn from feedback, you know? We want the feedback. So if you think this is for some, you know, if there's some reason why you think this isn't going to be helpful, I know that people don't like to speak negatively, but we'd like to know.
Yeah, and I think if it's okay with everyone, with Carol and Ian and others, I'm going to stop recording so that maybe that'll allow folks to speak a little more freely. Sound okay? Okay, recording stop.